Yeah, I think just those topics are more turn off.
Awesome. Cool. Do we know of any other researchers or academics that are planning to join us that we should wait a few more moments for, or should we jump into the topics that we have on the list already?
I think we should just run at this point. Um, we're 5 minutes past the start time, so if anybody wants to hop in partway through, then I think they can willingly accept starting in the middle.
Yep, sounds good. And I've also got the recording running, and I'll upload it afterwards. So we should be all good to kick off. Okay, great. So does anyone want to jump in and chat a bit more about the math working group? I've linked the HackMD in the notes here. Definitely some very interesting research areas. Is there anyone that wants to take a jump into explaining what's going on in the working group so far?
So I think the focus we decided on so far, in addition to the anonymous benefactor code, I mean, I think it's likely to be much faster. I haven't played with it at all, but the linear algebra formalism is likely to improve performance to the extent that it accesses better numerical libraries, not to the extent that it's theoretically. Does that make sense?
Yeah, definitely. Sorry, you were cutting out a little bit there.
Yeah, I'm sorry, but essentially, I mean, you can linear algebra tends to make things faster. You're just moving the additions and multiplications to a different place. But then if you can get like better numerical libraries to implement them, it can be much faster. So I'm really excited about the anonymous benefactor code. But the other thing we're looking at is, the optimal subgraph thing. We spent a lot of time clarifying the definition that the Block.Science group was using for optimal subgraph, and I think I understand it now. And looking at some different approaches to see um, how some other more formal, how some other approaches might compare to the meta heuristics. Like, are the meta heuristics doing a good job of finding the optimal subgraph, and if so, how can we prove or validate that? That's the main question we've settled on.
Yeah, that's an important question, right? Because whenever you're using meta heuristics, you never know whether you have you don't actually know whether you have the optimal. So as silly as it sounds, we're optimizing for the purpose of finding the optimality gap. But what we don't know is what the actual optimal is. So in a way, you need the concept of optimality gap in order to judge the optimality gap algorithm, which is somewhat problematic because if you don't know the real optimal value, the ground truth optimal, then the notion of optimality gap can get a little fuzzy. And so I think if you're expanding on our capacity to judge the optimals from which we measure the optimality gap, that's an important value add.
And so
Is that
I guess my main work in that area so far, I read about the first half of the book that you shared with, uh, and I feel comfortable trying to formulate it as a convex optimization problem. You you could make different assumptions and actually formulate it as a like a Lagrange multiplier problem. Would be
yeah?
even more straightforward, but then you would violate some of the assumptions that Block.Science set up about which moves were legal.
That's only sort of true, actually. So if you really take the primal dual method to its final extent, you can get to the point where you use the just for context, we're talking about this book Boyd and Vandenberg. It's the textbook on convex optimization that I used at when I taught the course at Penn, and in just for everyone else. And so Octopus has been working with that as a resource for moving towards the convex optimization formalization of this subgraph optimization problem, in a large part because unlike meta heuristics, the convex optimization problems have unique solutions and you can bound optimality gaps, and there's a lot of great stuff that comes from this. Sort of with that context, though, the primal dual methods, like the ones that use Lagrange multipliers, In there, if you solve for the sort of the dual solution, or the composite, the sort of the KKT conditions version of the problem that expands it to be both primal and dual at the same time, there are sort of notions that, to your point, um, you could get a solution that violates the constraints, but you can also sometimes converge still to a solution that solves the original problem. And that's what's kind of cool about it. It's like moving through imaginary territory, or like you move through otherwise infeasible solutions to find better feasible solutions. So I actually think you're on the right track, even with the introduction of the Lagrange multipliers and the sort of temporary like finding of solutions that don't meet the original problem statement. The point of primal dual methods is actually that in the end you can come back to finding provably optimal solutions to the original problem, including respecting the constraints.
Yeah, so what I'm viewing the solution, the landscape of the solution space that Block.Science has proposed is like a disc of an original solution space, and I'm working in what I think of as the original solution space. And then, my view, which may be off, I'm always open to feedback, but my view is that the discretization, or at least the potential discretizations, are likely to be very sort of densely packed within the original continuous version, which had no restrictions. So I'm agreeing with you that I think throwing out some assumptions might still lead to something that matches closely the real world assumption. My hope is to come up with actually something written that sort of formulates my current understanding of the problem to a point where I could get feedback from you by early next week about how valid or any ideas that anyone else. That's my personal update from the math working.
I think it's cool. For everyone else, I mean, I guess I don't know how many people are participating on this particular working group, but I will. I can link in the chat the same textbook. There's a public PDF version of it, and even some slides from Stanford on the convex optimization materials. And I do think this is a really valuable direction of inquiry. And to the extent that providing links to the topical materials in convex optimization makes this more accessible for those who are interested. I'll try to make them available, or as Octopus did, you can direct message me if you want, and I'll try to give you pointers to the relevant base material if you're interested in collaborating on this. But anyway, so I look forward to seeing that, and yeah, go ahead.
I'm curious actually if there's any more information on the discretization versus continuous. What is that, the something that's done for constraints of the model?
Well, like one of the assumptions, as I understand it, that Block.Science is making is that the set of contribution weights has to be preserved. Like whatever the optimal, however the original subgraph is modified to become optimal, it must preserve the set of contribution weights as well as the number of edges. And so that makes it not be like a pure optimizing over some real vector space, or even like a
It is a convex set, actually. Yeah. So actually, this is interesting, right? So that is actually a sort of, it's still convex if you take the sum of the contributions is equal to, or, and in fact, actually, you can think of it this way: is it's actually saying that it's less than or equal to, but then the solutions all land on the uh, the sum being equal, like it's a binding constraint. And this actually happens because the rewards are monotonically increasing. The match is monotonically increasing in the in contributions in the naive sense. And I guess, at risk of going into a bunch of details, I think the way that maybe
So
that
I need to stop you for a moment because
yeah.
this has actually been a point of contention that we've been trying to clarify.
Okay.
I originally understood that the sum of the contributions had to be the same. And then in asking further,
Mm-hmm.
it seems that the edge weights also be preserved.
If the edge weights are preserved, you're not actually changing the graph. So I wouldn't say that the edge
No, no, no.
weights are
The
preserved.
set of edge weights. So you would be allowed to move. So if you have 1 and 2 contributing to A and B,
Mm-hmm.
then 1 currently contributes 1 unit to A and 2 currently contributes 2 units to B, then you are allowed to move. So basically, I think the working group is unclear about which changes are allowed, even after
I gotcha.
discussion. So this may be something better formulated by a list of questions that I send you, but I think that, the math specification that I saw wasn't sufficiently clear to. There
Gotcha.
seemed to be hidden rules that weren't explicitly laid out.
Gotcha. I suspect that there's a gap between the formalization of the optimization problem and the meta heuristics, because I would formalize the problem as saying that we're only preserving the sum, meaning there's like a certain amount of money that this group of people has injected, and that we can totally rewire who's giving the money and who they're giving it to, which sort of assumes it's getting passed around behind the scenes, but it's still the same pool of money. But that so that's where the sort of sum of the inbounds being conserved came from. But this breakage then in terms of the implementation of the rewiring heuristics, I suspect that most rewiring implementations, the algorithms that we could get off the shelf, are probably closer to what you just described, where you take the existing edges and just shuffle them, because that's what's going to be available out of the box for using in a lot of graph tools. But that the optimization problem posed, to your point, should just allow the same money to get reshuffled into new edges. So for all that it matters, we could say that one person is going to take all of the money and they're going to donate it entirely to this one grant. And we happen to know that in QF, that's the opposite of what we want. That will result in the least efficient match. But finding the most efficient match is something that's a little trickier. We have this other sort of analytic heuristic that just spreading it amongst as many people as thinly as possible is sort of like the naive optimal rewiring, but that doesn't take into account the other edges that exist that might result in some potential points of leverage for heavying up in one place or another to take advantage of some edges that aren't in our control in this rewiring. But I think what we're digging at here is the gap between the formal specification of the optimization problem itself, which I think you got correctly with saying originally with the continuous version, and that the discretization is a consequence of the meta heuristics. Is that if we're using heuristics that are defined in terms of combinatorial graph rewiring algorithms, those tend to move edges around rather than treat it as a proper vector space. And I think, at least my opinion, is that the direction that you're taking with the convex optimization is a much stronger, a better way to approach this, but it's also more work. It takes more time because we have to more carefully unpack the problem and understand it more deeply than just grabbing meta heuristics off the shelf and trying to get them working in a hands-on code kind of way.
Well, I will email you or I will post the formulation of the problem as I. Any
Okay.
feedback would be appreciated because I want to. It doesn't help to solve the wrong problem
Yeah, I
unless
agree
you
with
are
you.
intentionally solving the wrong problem as an approximation.
I suspect that that is essentially where we're at. And I could also let Danilo comment on the current state of the meta heuristics, because my current understanding is the base problem is the one that you're describing, the one that could be expressed as the convex optimization problem, the one that exists over the vector space. However, we have graph objects and we have graph heuristics. And so the tooling available basically says, well, if you take this discrete approximation, then you can get up and running real fast. And then you're sort of tolerating the approximation that those tools assume. But the idea would be to unblock ourselves, make it so we don't need that approximation because we have both the formalization and the tools associated with the arguably better version, which is the convex one.
Well, I appreciate your insight, and I will work to produce something that can get further
Yeah,
comment.
I tend to agree with Z. I think that, let's say, having the continuous approach, I think it's more general than this greater one. And I think it captures better the, let's say, the goal of the optimization problem. Because, I mean, in order to you to do meta risk simulations, in order to do musical and so on, you need to have those discrete objects to still flow around. Because if not, you have a combinatorial explosion. But I think it's intuitive that let's approach. I mean, more stronger. So yeah, I look forward for that.
Cool. So I think if people are good, we can move on to the next topic. But Octopus, I will look out for that, and I'm happy to iterate on it with you a bit, because as Danilo just said, it's a significant improvement against the meta heuristics. It's just a question of, you know, um, there was sort of a degree of prioritization between coding and theory. And given our current project arc, we wanted to get first working code that did the job as a priority, but refining the representation and unlocking better optimization methods then can be sort of substituted into the pipeline and thus improve the overall process.
Ten-4.
Cool. So moving into the next topic on the agenda is the AI and reinforcement learning working group. Does anyone have an update on direction for that? And I'll just open up the HackMD to scroll through at the same time.
Yeah, I think maybe Jan, perhaps you can introduce the node-to-vec embeddings, and then we can also discuss how this might be applied to the problem.
Yes, I can definitely do that. So the basic idea is that we can use the unsupervised representation learning on the bipartite graph data of Gitcoin grants to build like a feature vector for all the contributors. And at the same time, basically, like before that, inject the attack vectors, similar to like what Block.Science is doing already. Then calculate a similarity measure, comparing the attack vectors and the empirical data, and then to basically surface the potential, basically the attack vectors into empirical data. That's kind of the idea. And if you basically scroll to the methodology in the question 1, a bit more up here. So you have this, yeah. So this is basically the whole process that I just described written down. And the biggest thing for me is the question whether this makes sense to you, or for example, like if you approach this problem this way, why do you think that this could work, or some better methodology improvements from your side?
We can't quite hear you, Danilo. Okay, he's muted. So in general, I'm a pretty big proponent of using unsupervised methods to discover solutions. I think the trickier part though is figuring out what to measure. My and again, sort of my experience is that this is going to depend a lot on how we choose to define the objective measures and the action sets available to the colluding agents who would be solving a reinforcement learning problem, which kind of lends me to want to um, proceed with the discussion of attack vectors, although Jaja's due only in about 5 minutes, because in a lot of ways, I feel like the reinforcement learning algorithm needs to be sort of hot started, right? Like if it's unsupervised, it sort of has to learn through playing the game over and over again. And so, some questions I have are related to how you would plan to produce the environments, or the literally, like you can imagine, simulated versions of playing the game of competing or attacking in the Gitcoin context, and then like learning from it. And I don't want to go too far on a tangent here, but this is a sort of a requisite part of training a reinforcement learning agent is to basically create a world model and then let those agents play in copies of that game until it starts to learn strategies. And so the hard part isn't necessarily the reinforcement learning algorithm itself. It's the creating the universe of worlds that the agent learns in. And the reason this is important, to be clear, is because it can only learn from the worlds you make for it. So just imagine for a moment that we create a bunch of worlds, and those worlds have some properties, and it learns a strategy that like leverages that property of those worlds. If you then release it into the real world and the real world doesn't have that property, that agent will flounder. So I guess what I'm trying to get at is I like the idea of exploring reinforcement learning based techniques, but the challenge sort of gets elevated one level to how do we design and deploy worlds. In a sense, in our case, essentially, this is going to be cadCAD models, so it's not unreasonable. But you would essentially have to use the cadCAD model to create instantiations of the game, and then you'd have to kind of allow your RL agent to play the game over and over and over again to learn how to get good at it. And then, I mean, I guess the real test would be um, how would that agent behave in the live Gitcoin system? And is there a way for us to say, well, if I was an agent in this Gitcoin system, I would do this, and then we look for things that are similar to what that agent would have done. It's a little bit, I guess, I feel like it's a little bit open ended. I wanna I'm really curious, or maybe I should say I would recommend that the RL working group sort of focused their effort on creating the, in a sense, the game of Gitcoin. So take the cadCAD model, take the real data, take your observations and your experiences and your intuition from using Gitcoin, and try to formulate um, a version of the game where the Gitcoin system evolves around, then the attacker makes a decision, and then the Gitcoin system evolves for a round, and then the attacker makes a decision. And one whole, and I guess by round here I mean game round, not Gitcoin round, or like turn, if you think about it this way. One Gitcoin round is a bunch of turns of some period of time, and with our Gitcoin models, like our cadCAD model, we're actually sort of iterating through agents, not the attacker, acting as the contribution graph fills up. And that if I were a reinforcement learning agent trying to learn to attack the system, I basically at each step in that process, I would make an evaluation, I would make a decision, and that would have a change to the state of that model, and then it would go again. And so you could imagine over the course of one full Gitcoin round, the player would have played out their strategy, and then they would get a payout, which was a final score, and that score would be their utility. And that if they did well, then the strategy they followed was good, and if they did poorly, then maybe the strategy they followed was bad. But in order to train an RL agent, you need to just do that again and again, and it can't be the exact same game every time. So you have to create a game generator. So like a variation of the cadCAD model with a mixture of real data and stochastic elements, so that you could throw your RL agent into the game, let them play, let them get a score, learn from it, and then play again and again and again. And eventually you'd have an RL agent that was actually good at the game, but they would really only be good at the game you had made for them. So then ultimately, if you've made a game that was a good reflection of reality, then the strategies they learned by playing it repeatedly would become good strategies for attacking the system. And thus we would have a proxy for what an attacker would do. So we would use that reinforcement learning agent, see what at any moment that agent might do, and we might look for people doing things that are similar to the things that the reinforcement learning agent would do. At least this is my perspective on how reinforcement learning would be applied to this particular problem. But it's also just an opinion, so I don't want to say like you have to do this, but I think that's the crux of a reinforcement learning problem, is actually building a copy, a generator even, of the game you want the reinforcement learning agent to learn to play well, because doing RL requires you to do it over and over and over and over and over again.
Yeah, like it's a very good point. I mean, like here, the let's say our group like kind of has different approaches to the whole collusion detection problem, right? And like this, for example, this approach doesn't involve any. It involves just GraphML. That's it. So basically, the node-to-vec embedding is just to build like a feature representation, let's say at the end of the round, right? And then we compare just on that static image. So it's a very simple POC in the beginning, and then we can, for example, stack complexity on top of that with reinforcement learning or any of those approaches, right? So the idea is to start simple and then build complexity over time, and not like just bite too much that we can chew, kind of, right?
Gotcha.
But
Yeah, that makes sense. I guess my response was probably like overtuned to the name of the working group, because I saw the AI and reinforcement learning, and so I was thinking about it from the perspective of how to apply that particular tool. But if you're doing a static kind of, okay, here's the end state graph, and then you're asking questions about how one would, like, what, I guess, feature labeled, like, I guess um you're labeling subgraphs or labeling individual contributions, and then trying to essentially, I guess, machine learn a kind of graph, either classifier or regressor. Like a regressor would take an action and return a match reward, or a classifier would take a action and sort of try to label it as honest or dishonest. Is that a better way to think about it?
Yes. I mean, that's basically the idea, right? That you have kind of like this graph of the attack vectors and the empirical data, and then you compare kind of like this feature vector, right, of the attack vectors and the empirical nodes, right, like the contributors, and then you can surface them and then see how they behaved over time, right? But that's obviously there's a lot of strong assumptions here, right? So that's why also like I wrote there that the initial POC is basically without any temporal dynamics, and then we can, over like iteration, we can kind of like incorporate that, right? And then just maybe also like use more complicated methodology, also including RL or all these things. But
Yeah.
the biggest
But
part
this
is
isn't, so even the problem you're describing, the simpler one, isn't really unsupervised, though, because you're using the attack vector research to serve as a sort of, you can inject and label attacks, because you need, in order to train either a classifier or a regressor that's able to help identify honest or dishonest, or even sort of like, efficient or inefficient in terms of, say, if I think of a regressor, I tend to think of match per dollar as the utility function that you would be fitting for. But in both of those cases, you need data sets from which to learn. Those are those are supervised, or maybe semi-supervised methods, but they sound mostly like supervised methods.
yeah. So node2vec is unsupervised, like
Okay.
basically learning, but because we inject the true values, kind of, right, like what we think
Right.
are attack vectors, how they could look like. That's why we basically transform this whole problem in a semi-supervised learning, basically problem, right? And then we can
Right.
surface the
But
signal, right?
Node to Vec is feature engineering. So feature engineering is unsupervised. So in like a machine learning fitting process, right? You have a sequence of what are essentially feature engineering tasks that take your raw features and convert them into new embeddings. There's new vector spaces in which you are discovering mappings from the sort of post engineered features to the labels. And so any ML pipeline is essentially the unsupervised component composed with the supervised component. So, and again, I'm just trying to unpack what you're saying. So what I see here in the node to vec embedding is part of your feature engineering process, but you would still then use those new features that you found and attach them to labels in a supervised workflow in order to get to either your assignment of predicted efficiencies or your predicted class that says attack not attack.
Yes. That's correct. That's correct. Yeah, are there like some other comments, for example, on the, let's say, on using something else other than node to vec, or for example, just this combining of, let's say, just as you said, like uh, the unsupervised and basically like in the end, kind of like a downstream task of of calculating the similarity measures. Does that make sense as a whole?
Yeah, I think it makes sense as a whole. I would say that when it comes to what I'm seeing in Q1, this is the kind of thing that, as a data scientist, you can start with a conjecture and then you just got to iterate. So you would use node to vec, and that would be your feature engineering workflow, but you would need the labels. So the next thing would be to make sure that you decided whether you were, I guess given the algorithms we've all already developed, we have the ability to at least compute efficiencies, right? You could just go in and say, well, what was my match? Well, I computed my match. What was my original input? Okay, that was this much. So there's a rate, which is the match funds per dollar direct contribution. And if you wanted to build a regressor over that from the graph, you would literally take every single event, you would node to vec transform it, and then you would try to fit a you would try to fit a machine learning algorithm using that feature space and the label space equal to the efficiency. And like basically, maybe it's good and maybe it sucks. And if it sucks, then you iterate on largely on your feature vectors, or maybe you iterate on which machine learning algorithms you use. But actually, at this point, machine learning algorithms are, especially in Python, you can use even ensembles. You can get pretty powerful stuff out of the box. So actually, most of the burden comes back to your ability to construct features, because that part's still somewhat creative, where the machine learning, the actual fitting part is often, if you just use the high powered ensembling methods, it will find you the statistically best ML pieces, but you still have to sort of bring your own creativity, your own exploration to help tell the computer the shape of the inputs, right? The feature engineering workflow. So it seems like a good place to start, but the practical experience of that will be get that first pipeline running, do some cross validation, see how it performs, and then go back to your feature engineering stage and iterate until you start to get results that are statistically significant in a sense.
Okay, that's very useful. Thank you very much. So there's also Mark, and like Mark also wrote down some things, so maybe like he can basically continue with his the application part, because I think that he also has some questions. Mark, would you like to continue?
Yeah, sure. Yeah, it's a pity that Owoki has left, I think, because I would like to ask his opinion about possible applications of our research. It starts with some behavioral patterns that are written on top of this document. Maybe we can take a look at that first. Yeah, so basically what I'm interested in this working group is how does this this Gitcoin round evolve over time? What are contributors doing? Are they showing some sort of strategic behavior? And Angela has written down this very nicely into, well, patterns that can be derived from the temporal, or what is evolving over time during a round or in between rounds. Like, for instance, you can see that maybe there are mature communities already there that already have a large set of contributors behind them. Maybe you have seed kind of patterns. So grants start with a small number of contributors and grows round by round with some sort of loyal contributors. Grants marketing, and only for on the same days, many contributors donate exact the same amount. maybe all these kinds of pattern we can derive from well, let's say looking at the data round by round, and maybe adjusting some sort of algorithms Jan talked about to have a deeper understanding about maybe subgraphing or how subgraphs evolve over time. So I was thinking about, okay, so when you once you have investigated and you can see certain patterns arising during rounds, how can you mitigate possible bad effects? And then we can scroll down to the latter part of the document on the applications section. I wrote down some ideas of how we can well, maybe let's see, deal with those kind of patterns. And I was thinking about, okay, it's if people are having a small or if there are patterns of small optimality gaps, um, is that some sort of sign of collusion, or is it some sort of sign of just strategic behavior derived from game theory, agents utilizing the rules of the game? Um, so it's difficult, I think, to look just for collusion patterns per se, but strategic behavior in common. And if you see, for example, mature communities arising, maybe you can implement some sort of algorithms to check for this kind of maturity patterns. Like, are there many recurring contributors? Are there whale contributors or semi-whale contributors, like an oligarchy of contributors pooling this grant to the end. Maybe you can say, okay, if I can see that kind of behavior, we can maybe apply some sort of algorithm or recommendation engine by nudging to consider other funding or to split the funding to other grants. With the seed pattern, you have basically the same, and I'm adjusting that or addressing this to the Gitcoin values, which are written a bit above here. There are 8 of these. You can, of course, compare these patterns to the Gitcoin values and see if there are some conflicts with those values in order to mitigate them by putting their new kinds of applications or some sort of recommendation engines which are looking at how the round evolves over time and then implementing a certain recommendation engine or a certain AI or an algorithm or some rule in order to mitigate some bad effect happening. Basically, this is what I was thinking about and would like to have some sort of feedback on that.
Yeah, so I mean, to first point about the collusion and the maturity, or like strategic behavior versus collusion, I think this is a real challenge, and this part of the reason why we have to think about collusion detection as not so much collusion detection as flagging potential collusion, so that there's always a normative process downstream to ensure that honest strategic behavior that is not outside of the terms and conditions isn't sort of sanctioned, because technically if you're following the rules, you're acting strategically and you're like within the scope of the terms and conditions in the sense that you're an honest actor just being smart, then you shouldn't necessarily be sanctioned. But that line ends up being subjective. So I'll sort of start by kind of agreeing with you, and that the overall solution architecture recommended accounts for flagging followed by human review, as opposed to strictly sanctioning based on the data only, precisely for this reason, that we can absolutely have strategic or intelligent, efficient behavior that is not violating the rules or values or the terms and conditions. When it comes, though, to the sort of next part you're talking about, where there's some more nudging or recommending, I think it's interesting to think about what kind of recommendation engine might help create visibility or circulation in the attention by the participants on the grants. I think it's pretty well understood that attention routing has a huge effect on grants. That, in fact, the grants that are at the top of the list from I guess there was some discussion, I think, in a previous one of these calls about, ordering grants when you show up at the page by which ones have had the most contributions in the past, or maybe ordering them, randomly, or randomly with weights based on how many times they've seen in the past, or, trying to find the right way to show a user who shows up at the Gitcoin webpage a list of grants. And I think that this is a really important problem, because even just doing it the same for everybody has some maybe some risk, because it still centralizes the attention of all of the users, and thus concentrates the choices to donate. If you could imagine a scenario where you had an Amazon like recommendation engine that said things like, well, when you arrive, I'm going to show you things that this algorithm thinks you would like, which is not necessarily the same things it would show me. Furthermore, having features like, well, people who like to donate to this grant also donate to that grant. I think a lot of that kind of thinking could go a long way, but I also caveat that that kind of nudging is also dangerous, because it can sometimes create new attractors or create new dynamics that could also be concentrating, but they might be more opaque. And you might be creating a concentration through a feedback loop in the machine learning model, where certain activities happen, and then the algorithms grow to believe that people like this, like things like that, and now people like this only ever donate to things like that, and they lose the capacity for discovery because the system's overly opinionated. So on one hand, I think, some scoping of the attention routing problem, where we say, suppose person X with metadata Y or features Y arrives. Now we must choose from the set of all grants how to essentially score them on a per person basis, and then show them to you in an order that's sort of unique to you, as opposed to in an order that was determined globally. I think that has a lot of potential for giving more exposure to more grants and widening out the donations. But I think that there's a sort of insidious risk that those algorithms, um, if they're, I say insidious. Basically, it's possible to create a scenario where you are biasing people towards some things and away from others without totally realizing you're doing it. So it would be treated from a trade-offs perspective, like the introduction of features related to attention routing as a, again, I think of it as a recommendation engine. Collaborative filtering is probably the right route. Fits in with a sort of Amazon style recommendation engine pretty easily. It would be possible to POC such a thing by using historical data and looking at people. Again, well, historical data is like a little bit of a question mark here, because I think there's also a question of, we have anonymized data, and that you need the attributes of the donors in order to do the collaborative filtering. Because you have the attributes of the donors cross the attributes of the grants they donated to, but ultimately this is, again, same kind of bipartite graph, like donors with these attributes donated to things with grants with these attributes. Therefore, since you have these attributes, you might like this grant. Uh, I I don't want to burn too much time, but like, I'm kind of feeling out how I feel about this, and my instinct is it's a good thing up to a point, but you'd have to be leery about overdoing it.
Yeah, thanks. Yeah, I can agree.
Um,
Cool.
and to be clear, a lot of the person that you identified a bunch of different characteristics, and they might be, features of the contributors. Like, there are other features of the contributors, but there's some second layer stuff which are, contributor level attributes, and I think you've done a good job identifying some potential contributor level attributes that could be culled from the data. It doesn't necessarily tell me how useful those attributes end up being, but it's always a good starting place to be able to, again, like, take the data and mine out of it some attributes that you could use as the backbone of such an algorithm.
Yeah, credits go to Angela for the behavioral patterns.
Cool.
Very
Was
cool.
there one? So just as a note, I chatted with Jaja quickly, so she got tied up. So since we seem to be having pretty productive discussions, I told her not to worry about it. We have probably enough time for like one more topic if anybody else wants to kind of lead on. Even just asking, posing questions is fine too. They don't have to be things that we have answers to yet. I mean, if we're good on topics, we can. I mean, people can we can finish up early. Alternatively, we could just have a moment of reflection on sort of, is this productive for people? Like, this is, we have these now every 2 weeks as sort of just like catch up sessions, almost like office hours. I prefer running them more like office hours than like presentations, because it gives people the most opportunity to engage in discussions and explore new ideas or explore the ideas you guys have been researching. Is this a good format? It's like,
I
Well,
enjoyed
to
this.
some extent, I mean, I know that always hard to cut out time of your daily business, but I feel that in 2 week iterations, of course, there happens a lot in the background, and there might be also some, let's say, uncertainty that should be solved earlier and probably quicker, um, with a particular approach or a current status. So I don't know if we could have shorter but weekly sessions. Not sure.
I mean, it might be suitable just to like, I mean, if we escalate questions, they don't have to wait until office hours
Mm,
necessarily. I'm trying to create an opportunity though for people to go out and do stuff and come back with like, hey, I tried these things, because you learn a lot more that
yeah,
way. So like, if you just, if you have an idea and then you immediately just go into a, you know, office hours, versus if you have an idea and you play it out and you got to like try it and see what you learn, and then I have questions that arise from doing things. I find
yeah,
that to be a much more productive way to learn. So I mean, again, it's an opinion, but like, the idea here is that we have the hacking sessions, we have working groups, people are, I have gotten some DMs, like I thought it was, I very much appreciated Octopus reached out about convex optimization, we talked about it a little bit. Like, that's fine. I just think that at some level, keeping these slightly more spaced out helps incentivize people to go try to solve their own problems too, because that's a good way to learn.
sure.
And I think also inherent in these kind of like research and exploration initiatives is, um, I think and this is something I've realized being in a bunch of different research initiatives over the past year as well, is that there's a lot of the work doesn't end up in the output, but that doesn't mean it wasn't an important discovery. A lot of the time, science is learning what we can't do, or what we shouldn't do, through the process of doing it. So there's a lot of the learnings feels like it's thrown away, but ultimately it's just kind of an invisible part of the output. So I think that these kind of like open research initiatives, we need to kind of leave space for that exploration that doesn't necessarily feed directly into the finished product.
But the finished product of that process is the learning itself, right? So what you just described, where you learn stuff even if it doesn't work out, like, my experience is that that's absorbed. That residual is in the person who did it, which is part of the reason why I'm trying not to cut out the process where you try stuff and if it doesn't work out, whatever, because like, that's literally part of learning. So, to Jeff's point about research, I guess what we're trying to accomplish here is to expand the overall capacities, knowledge, experience of this community, and apply that capacity to Gitcoin and other projects of interest. And I guess I want to reinforce the importance of learning by trying stuff, even if it doesn't work. And if we go too far ahead and say, oh, no, no, you should do this instead, then you're actually missing out on the opportunity to learn by having an idea and trying it and coming forth and saying, hey, I tried this thing. And you might say, hey, and I learned it works great. Or, hey, I ran into this problem. What should I do next? But you still actually learn a lot more if you try it first.
I will say that from sort of a community standpoint, there could be an issue with newcomers not being like thinking that everyone there's imposter syndrome and people think that I shouldn't ask this question because everyone else in the room already knows this and I don't want to highlight myself and how little I know. So I think having some type avenue where it was clear that beginner questions were welcome, clarifying questions were welcome, doesn't necessarily have to be a chat. Does that make
Yeah, that makes sense. I think so we can be more, maybe one thing we can do with the sessions too is reserve the first like 10 minutes or so for like introductions of new members and or clarifying or otherwise beginner questions. Not that you can't ask beginner questions whenever, but maybe by just opening up a space for people who are either new to the group or specifically want to ask sort of beginner questions, it's a little more inviting because I get the point. I think it's worth trying to make a space that feels more inviting.
Yeah, and I also want to encourage everyone to drop in updates on the work, be it code or be it an update on a document or just a thought, to share it on the Discord channel. So don't hide it in direct messages if you dare. But I think it's really even these approaches, as you said, that failed and that doesn't lead anywhere. It's worth sharing, and we would all benefit. So yeah, please do share your insights in the Discord channel.
Negative results are results. I think probably one of the
Exactly.
biggest problems with modern academic science is that negative results are repeated constantly because no one shares them because it's just not incentive aligned. And creating a space where, you know, it's okay to have negative results is actually, I think, very valuable. And so for whatever that means, I know that no one wants to share like, I tried this and it didn't work, but it turns out that's actually valuable. So yeah.
Exactly.
Cool. Well, this was a great discussion today. Really happy to have been a part. Sorry I couldn't stick around for the whole live coding session, but that sounded like it was a great exploration of the linear algebra Einstein summation stuff. So yeah, really looking forward to see how this progresses in the next week. And yeah, so we've got next week, we've got another Token Engineering Academy session on Tuesday and a live coding session on Thursday. All events can be found in the Token Engineering or the cadCAD calendars. And yeah, looking forward to chatting more next week.
Okay, thank you all.
Okay, everyone.
Thank you.
Thank you.
Bye bye.
Thanks, everyone.
Thanks, everybody.
Thank you.